Okay, hello. So let's look at what is Biot Savart Law. And for this, the background is that, as you can see here, there is a current carrying conductor which carries a current I. And because of that, let's consider a small element dl of the current carrying conductor, a small element. And because of this element, there is a magnetic field produced. I mean, because of the current flowing through a conductor, there is a magnetic field produced. But let's focus only on the small element of the current carrying conductor and the magnetic field it produces. Let's say at a distance given by this vector, displacement vector r, at a distance given by this r vector at point P, there is a magnetic field dB of magnitude dB that is produced. This is the background. Now, what does Biot Savart law state? The Biot Savart law states that the magnitude of this magnetic field is directly proportional to the current flowing through the conducting element length itself, that is dl in this case, which is small, and inversely proportional to the square of the displacement vector, or the distance, inversely proportional to the square of the distance. So we can translate it to the magnitude of magnetic field is directly proportional to I dl by r square as given here. Now let's look at the vector notation for this. In vector, this becomes a dB vector. It's directly proportional to I, and the length becomes dl vector, and we have r square. But for converting this to vector, we can multiply this by the unit vector r cap, given by r cap in the direction of r. For any vector, when we multiply the magnitude by the unit vector, we get the actual vector. What I mean is, in this case, let's consider the magnitude of the vector r. When we multiply it by the unit vector in the direction r cap, then we get r vector. So we can replace this unit vector using this equation, and we get I dl vector divided by r square times, when we replace r cap, by r vector divided by r magnitude. So this becomes r vector divided by r. So we multiply it for the cross product of both these. Because why do we do that? The magnitude of the magnetic field is dB, but the direction is perpendicular to the plane of the screen. When it's perpendicular, that's why you represent it as a cross product notation. So when we do dl cross r, we get a direction of dB vector is perpendicular to the plane containing the dl vector and the r vector. Now what happens is, this becomes, when we multiply it by the constant mu naught by 4 pi, where mu naught is the permeability of free space. In magnetism, it's permeability of free space. Mu naught by 4 pi for the proportionality constant, and then dl cross r becomes dl times r sine theta. So dl sine theta, the r and the magnitude of r and this r get cancelled, and we get r square again. So this is the magnitude of the magnetic field produced at a distance given by r vector, the displacement vector r, due to the element dl in a current carrying conductor. That's what the Biot Savart law states. Thank you.